morning. In our lesson today, we're going to look at Cramer's rule for a 3 by 3 linear system. You might recall that in the previous lecture, we studied the 2 by 2 system and Cramer's rule as the method of solution. So the method is very much the same for a 3 by 3 system. We now have 3 linear equations, but there are 3 unknowns, x, y, and z. And we'd like to know where the 3 straight lines are crossing in 3 dimensions. So just like with the 2 by 2 system, the first thing we do is calculate a determinant called capital D. And it is formed by taking the coefficients of x and placing them in column 1. The coefficients of y will be in column 2. The coefficients of z will be in column 3 like this. Now evaluating a 3 by 3 determinant is different than evaluating a 2 by 2 determinant. There are a couple of different ways. One method is called cofactor expansion. I won't present that here, but if you've learned that in a previous course, you're certainly welcome to use it. The method I'm going to show you once again involves products and also subtraction, but it's a little more complicated than this 2 by 2 determinant. So what we do is we repeat the first 2 columns. So I would write that first column here and that second column here. So when we're done, we actually have 5 columns like this. And then, once again, you'll be taking products. You'll be subtracting and taking more products, but instead of just 1 product in each direction, now we're going to have 3 products in here and 3 products in here. And within these brackets, we're adding the products. Okay, so this is what I mean. The first product is the multiplication of A1, B2, and C3. Plus, the second is the multiplication of B1, C2, and A3. Plus the third product, C1, A2, B3. Okay, so we formed 3 products in the principal direction like this. 1, 2, 3. So you take 3 products and you write them in the first bracket, and again, you're adding those quantities. And then there will be subtraction, just like there was here, but now there will be 3 products in the other direction. Okay, like this. The first one, A3, B2, C1. Plus the second one right here beside it. Okay, so the multiplication of these 3 guys here. So, you know, we can write these in any order within the term, but I'm just using alphabetical. So it's A1, B3, C2. And plus 1 more right here. A2, B1, C3. Okay, and then you know, you work out this number, do the subtraction, and you'll have your numeric value for capital D. And then that is your denominator for X, Y, and Z. And you form the numerators by replacing one column with the numbers from the right-hand side. When you're solving for x, it is the first column that gets replaced with the numbers from the right-hand side. Okay, so the second and third columns remain as they were. When you're solving for y, the numbers from the right-hand side will be right in the middle. And the first and the last column will be as they were. And lastly, since z is the third variable, the numbers from the right-hand side will be in that third column. First and second columns remain as they were here. Okay? Okay, so we're going to now try a couple of examples using Cramer's rule. So here is a first example. We have our three equations in three unknowns. So we're going to start by forming that first determinant. All right, so here, of course, the implied coefficient of x is 1. So in the first column, I will have the numbers 1, 2, 3. In the middle column, the numbers will be 2, 1, 4. Again, this is implied to be 1y. And in the last column, 3, 2, and -3. Like this. And so to evaluate this now, I have to repeat the first two columns. Now I'm going to form three products in each direction using subtraction between the brackets. Okay, so let's do the first direction. So it's 1 times 1 times -3. And to that we add 2 times 2 times 3. So 12 is added. And to that we add 3 times 2 times 4, or 24. Okay, now we change directions and we form three products. Here we go, 3 times 3 times 1. And to that we add 4 times 2 times 1. And finally, we add 2 times 2 times -3, which is -12. So -12 is added like this. And now all we have to do is work out these numbers. So in here, what are we gonna get? We're gonna get 33. So the first bracket is 33, subtraction sign. And what do we have in the second bracket? That number is 5. So the value of D is 28. Lovely. So now I need to come up with my determinant for the numerator of x. Okay, so remember that once we get our answer, we're going to be dividing by 28. Like this. Okay? So we're using this right now. We'll put the 28 underneath, you see? And now we're about to form the numerator. So the numbers from the right side will be in the first column. So that means 14, 10, and 2 will go into column 1. And columns 2 and 3 remain as they were. So 2, 1, 4, 3, 2, -3. Okay? Now to evaluate this 3 by 3 determinant, we have to repeat the first two columns of the determinant. And then we're going to do our three products in each direction with subtraction between the brackets. Okay, now under here, of course, again, I would have an over 28 still, but I don't feel like writing that all the time, so I think that on the left, I'm gonna instead write 28 times x, okay? And we'll remember to divide by 28 after we're done here. Okay, so let's get started with our three products. So it's important that we go in this direction first, always, okay? 1, 2, 3 products. So here's the first one, 14 times 1 times -3, so that's -42. Oops, moving my paper around there, sorry. Okay, the second one is 2 times 2 times 2, so +8. And the third one, 3 times 10 times 4 is +120. Okay, let's change directions. 2 times 1 times 3 is 6. And then beside it, 4 times 2 times 14 is 112. And then last one here, -3 times 10 times 2, that's a -60. Okay, so this is 28 times x is, okay, so inside this bracket now, what do we have? -42 plus 8 plus 120 is 86. And then from that, we subtract what's in here. 6 plus 112 minus 60 is 58. So we have 28 times x is, we take the subtraction here and we get 28. And so what does that mean? That means x is equal to 1. Okay, now we're going to go ahead and do the calculation of y. So I've got my 3 by 3 determinant to set up like this. And remember that underneath would be over 28. But again, just to avoid having to do over, I'm going to just write 28 times y equals, and now how is y formed? You probably remember, but just in case, the numbers from the right side now go in the middle. So the 14, 10, 2 are right in the middle. So now I have to fill in the first column and the third column based on the original. So from the original D, or you could look back here. Okay, so from the original capital D, I know that this should say 1, 2, 3. And for the third column, from the original capital D, this needs to be 3, 2, -3, like that. How do we evaluate this 3 by 3 determinant? We have to repeat the first two columns. And now we're going to make 3 products in the principal direction and write them here. There we go. 1 times 10 times -3 is -30. 14 times 2 times 3 is 84. And last one, 3 times 2 times 2 is 12. Okay, switch to the other direction. 3 times 10 times 3, or 90, plus 2 times 2 times 1, so plus 4. And then we also add -3 times 2 times 14, which is negative 84, like that. So this is 28y we're working on, right? This is still 28y. So 28y is, okay, so what is this number? You just punch it in directly into your calculator like that. You'll get 66. Okay, from 66 we are subtracting. This number is 10. So now we know that 28y is 56. Therefore, what is y? 56 divided by 28, or 2. Okay, now look, we have x, we have y. We could do one more determinant if we like to figure out z using this method right here. However, if you've grown weary of this, you can instead use substitution now because we know 2 of the 3 values. So we could substitute x is 1 and y is 2 into any one of these 3 equations in order to figure out z. So for example, if I just go to the first equation right there, remember, we can substitute. This would be 1, so we will have 1 plus 2 times 2. Remember, this means multiplication. Okay, so 1 plus 2 times 2. So I'm substituting into this equation. 1 plus 2 times 2 plus 3z is 14. In other words, 1 plus 4 plus 3z is 14, or 5 plus 3z is 14. How do we solve this for z? Well, first we would subtract 5 from both sides. So 3z is 14, subtract 5, which is 9. And z is 9 divided by 3, so z is 3. And now I have my z value. And just like with the 2 by 2 systems, we write this such that it looks like a point of intersection. But in this case, we need x, y, and z. So I don't know why I spaced it out so much, but anyway, it's 1, 2, 3. So this is the point of intersection of the 3 straight lines in 3 dimensions, 3-dimensional space. Okay, you could check this answer by substituting it into each and every equation. For example, if I substituted into the second one, 2 times 1 plus 2 plus 2 times 3. So that would be 2 plus 2 plus 6, which certainly is 10. Check this one as well. 3 times 1 plus 4 times 2 minus 3 times 3. So that's 3 plus 8 minus 9, which is 2. And it'll work in this one as well. So you would check that the point satisfies all 3 equations, and then you would know that your answer was correct. Okay, let's do one more example of this together. Okay, so the first equation has all 3 variables in it, but you can see that the second equation only involves x and y, and the third equation involves x and z. So what does that mean? It means in the second equation, the coefficient of z is 0. So it's as though at the end here, it's plus 0z. And the same is true for the last equation. Since y is missing, then in between these terms would be plus 0y. And this is important because you want to make sure when you set up your capital D that you are setting it up correctly. Okay, so you have to make sure that in your first column, you put the coefficients of x. So remember, this means 1x, 1y, 1z. So what are the coefficients of x? 1, 2, and 2 respectively. What are the coefficients of y? 1, -3, and 0, because there is no y here. So 1, -3, and 0. And what about the coefficients of z? 1, 0, and 3. Okay, so again, the coefficients of x, 1, 2, 2. For y, 1, -3, and 0. And for z, 1, 0, and 3. So just like that. Okay, now to evaluate, it's the same. We repeat the first two columns. And we form our products. So in the principal direction, we have 1 multiplied by -3 and +3, so that's -9. But the next two products are zeros. Right there, right there. Okay, so +0, +0. So now we can change directions and get our three products. Here's the first one. 2 times -3 times 1, which is -6. Now the second product is 0. And the third product is 3 times 2 times 1, which is +6. Okay, so what do we end up with here? We end up with -9 minus 0. And so the value of D is -9. Okay, let's set up our X determinant. So how is this determinant formed? The first column gets replaced with the numbers from the right side. So this column is removed and replaced with 90, -20, and 145. The second column will stay the same, and as will the third, like that. Remember that we would have here over -9. We have to divide by -9 after we evaluate the determinant. So the alternative is to write -9 times x is equal to this determinant. Let's evaluate it. Okay, so we're going to evaluate that determinant. Principal direction. So we go this way first. 90 times -3 times 3 is -810. Now look, this is 0. 1 times 0 times 145, and this is also 0. 1 times -20 times 0. So we've got -810 minus. So now we go in the other direction. 145 times -3 times 1, that's -435. The next product is 0, but the third one, so to this number we add 3 times -20 times 1, so we add -60, like that. Okay, so now -9x is, this is -810 minus, this number is -495. So it's -810 minus a -495. And that's the same as negative 810 plus 495. And this is equal to negative 315. So x is found after dividing that number by negative 9. So negative 315 divided by negative 9 is going to give you x is 35. Just like that. And if you really like evaluating these determinants, you can do it again to find y. You can do it again to find z. But since equation 2 only involves x and y, and we now know x, we can substitute it and solve for y. And same thing with equation 3. If we substitute x, we can solve for z. So I think I'll do that, okay? So first I'm going to go to equation 2. So let's make a star here. And equation 2 looks like that. And I'm going to substitute 35 for x. So this is 2 times 35 minus 3y is negative 20. So that's 70. So 70 minus 3y is negative 20. So I'm going to solve this for y. So I'm going to move the 70 to the other side. It will be subtracted. So negative 3y is negative 20 minus 70. Of course, that is negative 90. So what is y? Y is negative 90 divided by negative 3. So y is 30. Okay, now I know x and I know y. All right, to find z, I could either substitute into the first one or the last one. I'm going to use the last one here. So I'm using a different kind of star. Some kind of a star. Okay, and we're going to substitute into this equation. 2x plus 3z is 145. So I'm taking this. Now listen, if I'm going to use substitution here, I should say that I have to be, fairly confident that I got my x value correct, because otherwise I'm now using an incorrect x value within these calculations. So be very, very careful. Make sure you've done this correctly and then go ahead and use substitution. So again, this means 2 times x, or 2 times 35 plus 3z is 145. That's 70. Okay, how do we isolate z here? First, this term is moved, and it is moved. We change to subtraction of 70, like that. So we have 145 minus 70. This is 75. And so z is 75 divided by 3, or 25. Okay, so, yeah, I know I'm fussy. I have to fix that. Or not. Okay, there we go. So now we know x and we know y and we know z, and we write it as, we call it an ordered triple. So an ordered pair is what you get when you solve a 2x2 system. This is called an ordered triple. So x, y, and z in that order. And you could check that this is correct. You could substitute into equations 1 and 2 and 3 and verify that left and right sides come out equal. And that's how you can check your work. Okay, so this is how you use Cramer's rule to solve a 3x3 linear system. Once again, this is one method right here that I showed you today for evaluating a 3x3 determinant. But there is another way. It's called cofactor expansion. Some of you may have learned this. I think maybe some of the international students will have learned it, and also students in Canada who have taken some of the math courses intended for university-bound students, then you would have learned cofactor expansion as well. Okay? All right, and you're welcome to use it, is the point I'm trying to make. All right, have a great day, everybody.